will kick off the panel discussion. First of all, my first question will be to my colleague Pankaj. I think if you look at your overall experience and you lead a market leader in its segment, right, in this space, how do you think that AI is creating measurable business impacts, right? Um, beyond the concepts, and if you can throw some light on what you're doing or thinking of doing in terms of those initiatives.
So if you look back, then AI, as a buzzword, it wasn't experimental. Even the students in colleges, universities, they were experimenting, right? And one thing which was missing was the trust. How we can basically make it sort of business result oriented, where these are operational efficiency. How we can measure that what we are gaining from it in the terms of operational efficiency, in the terms of financial impact, in the terms of better customer experience. So that connect, and at the end, the trust. If I'm using something, like a black box happening inside, and as a leader, we need to trust. It is we are going to gain. So that's something in 2026 is no longer, like a experimental thing. It's now what we call we need to use AI for industrialization. And we are using, use case by use case, where we see it's not sometime from the R&D perspective, we do experimental as well, but any use case we pick, we look at, what we will gain in the terms of business, impact we are creating, customer experience, are we solving that? So what we're gaining, that objective driven use cases we pick when we solve it. And then any result which is coming, how basically we know this is something, a true picture. It's not a, false result. And we can, basically have that confidence to use it in a business, right? Now, from the manufacturing, industry perspective, we have IT, OT. So we have operations technology. So we have, different, from the shop floor perspective, we have different, say, if you look at a manufacturing shop, we have, arc furnace, we have ARD, we have LRF, we have, different things. And then we have different technologies, SCADA, PLC, creating all that data, right? Now, good part from that data is machines are not lying. So if you look at other industries, for example, BFSI, right? So you have card customers, might be they're lying, they're getting defaulted. But in machines, they're not lying. They are producing, content data. And you have at the second level, if we are not saving that data, so solving problem will be experience based, is a decision based, right? And that's something where, that trust comes into the picture. Now the industry mode, with AI is the conditional, or what we call conditional based maintenance, right? So where we have developed AI models, for example, these AI models are developed on the past sensor data, PLC data, like we have thermal data, we have vibration data, different type of data we are capturing, the rolling, speed, all those things are getting captured. And then we train our models on that data, aligned with the, the type of failures we had with those trends, building the confidence, if we are taking decision, using the AI models. And then these models are deployed and, working. And then basically, let's say if machine is giving one type of trend, we know, machine is going to fail, right? So this is something now saving us. We know the trend maybe a day ahead or maybe 1 hour ahead, right? It saves a lot of things. So one, it saves the hardware, which is, very expensive. It saves in the terms of outages, machine failure. It increases the production, the productivity we have. So it is solving many things. So this is, one example from, there are many examples we will discuss.
And from your perspective, I think what have you seen change in the operations. And we touched about operations maintenance on the aspect, but just reflecting on what Pankaj just mentioned, uh, what's your own perspective and experience on that?
Recently, I have enabled one of the AI models into that. That is on the QC. After the manufacturing, there is a every manufacturing unit there is a end with the QC only. After the QC, the material is go in a warehouse or a rejected portion. So we have put one device is on a QC panel. So that device help my team to recognize the defect and the variations faster than the human doing. Previously, it was managed by the human only. All the manual returns and all that. So now it was become more faster, more quicker, and more cheaper also. So that role has been taken by machine. So that was we have implemented just now on a QC panel. Second thing, so we are also put AGV in a warehouses. AGV is nothing but it's an automated robot. I would say the forklift, which can go and reach to the concerned warehouses, concerned bay, concerned bin, and pick, read the QR code and pick the desired material, and then the uh, forklift come directly to the loading points, and there is no man required. Previously, there was 50 plus manpower was just to manage the forklift and all these operations. But now we reduced by only 8 people because all the in-house operation was taken care by automated forklift. So this is one more use case I would like to share with you. So that can help manufacturing industry to
Yeah.
go for getting more benefit from using AI.
So now, Animesh, from your perspective, and we keep on hearing about this word of digital twins everywhere, right? And we have seen also. So, in your context, what does digital twin really look like, and how does it help the business in your perspective? And link it a bit with the AI.
So when we talk about digital twins, in terms of so basically what we do is we mirror this entire supply chain, right, into a model, and that kind of gives us a lot of perspective into answering questions which are otherwise quite difficult to answer manually, right? So I'll touch upon two parts. One would be the practicality of building such a system, because in a what do we call utopian vision, it really looks great that everything will be plugged in and data would be flowing seamlessly and everything would be there. But in reality, so the practicality is basically that it requires a lot of integration with a lot of diverse systems. All sorts of ERPs, all sorts of demand planning solutions across different, and even the level of maturity and the quality of the solutions that are deployed across the industry, they also vary a lot. So building such a network level digital twin is kind of easier said than done, but that is what we have been attempting, and that is what we have largely kind of built, which helps us a lot in our operations. So that would be around the practicality. And in terms of, I think, the value benefit that we derive, so there are certain kind of questions that we are now able to answer very confidently, right? For example, if a senior leader wants to ask that how does my whole operations get impacted, let's say if a key supplier in a certain region kind of goes out for 2 weeks, so if the only vision we have is inside the factory floor, if that is all the data that you are consuming, then probably this kind of answer won't be derived right easily. And in an earlier version, let's say 3 years back, if you wanted to do this, it would probably take a team of manual people working on spreadsheets and deriving that answer, right? Similarly, let's say you want to know that if we see a spike in a demand for a certain category of product, let's say by 15%, how is it going to impact my working capital? How is it going to impact my inventory levels? So those kind of questions we are able to kind of answer in a much more confident manner. So that is where we are seeing the highest and the biggest impact of building this digital twin.
Now, Pankaj, from your perspective, I think you talked a bit about data, right? And data is the fuel for everything that is done here. I mean, all that we are saying. But manufacturing systems also have a lot of legacy, right? I mean, different companies, different hardware players would have put different kind of systems on different machine, whereas you run one integrated operations, right? So, what have been, or what do you see as the biggest data integration challenges in scaling AI across plants and partners and whatnot, the diversity of the ecosystem? What has been your own experience?
If you look at, manufacturing from IT and OT perspective, one is the information technology systems. So generally, it is in good shape. We have standard softwares available for ERP, CRM. So data is already in a very good shape there, right? On the other side, on the operations technology side, which, on the plant side. So like I talked about, depending on, what level of automation is there, is it completely still on paper based, or and trust me, even for one company which has multiple plants, they can have, their plants in different level of automation, because moving from one level to next or other level of automation is not a one day task. It takes time, it takes lots of effort. It also, require planning along with the production. Is no production impact. Once this data is there, then we need integration with IT systems. So we cannot have, this is something in silo data which is there in the terms of only the operations data. So we need to integrate the IT and the OT systems in the terms of, marrying the data coming from the ERP, from the CRM, then coming from the edge systems, and what level of, data our edge systems is producing. We need to design, that level of data lake, data warehousing, right? And then AI is coming to the picture to ensure, we are leveraging this information which is captured. One time we use this approach to create now this approach, which approach is, working best for us in the terms of cost, in the terms of, faster, reducing the defect, all those things, or solving a R&D problem. So I think those are things, where data is solving, not deep thinking is required, capturing of the data, marrying the IT OT systems, then thinking of future problems.
Oh, great, great. No, I think just the appreciation of this point is very important because it's not a very straightforward kind of thing. So, and you have lived through these complexities, I guess, for a long time as well. So, no, I think this is very enlightening. I think, would you want to touch upon the aspects of, let's say, we talked about maintenance, we talked about production, quality, right? For example, so how does AI enable you to do, let's say, quality management or control in a way which is very different from the traditional ways?
So, as I recently referred, we have implemented one use case in QC. So, before putting this model in QC, we have trained the model with the various defect, various visual effect, various quality effect, various thickness, strength kind of defect, and over the period the model has been trained enough, and then we have put this model on a QC department. So it was put it on a ramp where all the tiles has been passed through of that model. So model will check thickness, color, variations, design defect, color defect, shade defects. These all things we have trained the models for almost more than 3 to 4 months, and then after we could able to see the different. Still the model is in learning phase, because the human what human was identify, there are a number of effects that human learn over the period. So AI has to learn all the defect. Yeah, AI can do the things faster, but still the defect are still coming up. So still it is in learning phase, but yeah, it's making more faster. Previously the human was able to do the check in a 10 seconds, AI can give result in 2 seconds. So that was a difference we can see after using the AI models on the quality checking.
A business happens when there is trust, right? So how much you actually trust AI to give you the right thing, and how do you create that trust of, let's say, and this especially to you, because you work in the ecosystem of companies, which anyways is working on a lot of trust, right? And AI has not become another dimension. So how does that come into play?
What has helped in our case is basically any kind of decision or any kind of output that the model throws. We always have a concept of show me the reasoning behind it, right? Which I think would typically also happen if you were to have a team member who comes up to you and says that we should probably order this material from so and so supplier, and then you would also probably ask, preferably, I mean, in case the guy was a new person, right, in your team, you would typically ask, what is your reasoning? Why should we do that, right? So in our case also, what we are doing is that the AI, in most cases, it acts as a co-pilot. So let's say it's a procurement co-pilot, right? So it will say that, these are the POs that we want to process, these are the supplier scorecards, these are the suppliers, and this way the PO should be released. But we always have a human in the loop check, which helps us to kind of set the guardrails, because I think we didn't touch upon the hallucination part, but that is also interesting because hallucinations and trust, they go hand in hand, right? And unlike consumer AI applications where the impact of hallucination would probably be that instead of 5 fingers you will find 6 fingers in an image that you generate. In case of industrial AI, hallucination might have you ship a product to a factory that does not exist, right? Or you might place an order to a supplier who might not be having that material or might not be dealing in that category as well. So when we are doing industrial AI, at least at Moglix, we are about setting very strong guardrails. And at each stage of this entire AI journey, right, from because we work with like ecosystem, right, from end to end. So at each stage there is a human in the loop process, and there is a reasoning that that the AI is able to show. So I think it takes time, but over time people build trust on AI.
So with that, thank you very much for your time, and wish you all the very best in your AI journey.
Thank you.